Hello everybody, welcome to the Beamable release video for October 2022. Let's go over some of the highlights from Beamable 1.4 through 1.52. We've added the Beamable Party SDK, so let's take a look by opening up a sample script. The Party SDK allows you to coordinate your players before they enter a match together. So in order to get started, let's acquire a Beam context, and in this case we will use a specific Beam context for some given player code that we can have as a public field. This will allow us to have multiple players all in the Unity editor for testing purposes. So let's make this the Beam context, and we'll also make that as a public field so that we can see it. The Party SDK is available through the Party accessor. So let's assign that to a variable, and then also we can store that in a public class field. And now the first thing that we'll want to do is one of our players will create a party. So in order to do that, let's make an async void create party method. And let's put a context menu item on this so we can call it from the inspector. We'll use the party variable and call create. And we'll need to pass a party restriction. And for now, we'll leave it as invite only. This is an awaitable expression, so let's just make sure we do that. The next thing we'd like to be able to do is invite a player to our party. So let's create another method by copying this one, and we'll just change this to invite to party. And now instead of creating a party, we'll send out an invite to a specific player ID. Let's have this player ID be a public variable that we can set from the inspector for demonstration purposes. To set this up in Unity, I'll go ahead and create an empty game object and assign it the sample script. Let's give this a player code of player 1, and now I'm going to duplicate this object to simulate having two players in the scene, so I'll call this player 2. And to keep my scene tidy, I'll change my game object names as well. On player 1, I'll go ahead and use the create party option, and when I expand the party, I'll see that I have a party ID with one member. This is my own DB ID. Let's switch over to the player 2 game object, and if we look at their context, we can go ahead and copy that gamer tag. And in player 1, let's enter the gamer tag here and use the context menu to invite the second player to our party. When we do that, on player 2, we can expand the received invites section to see that we have one pending invite to the party. Let's go ahead and add the method to accept the invitation. We'll need another async void accept invite method. And here we can use the party received party invites list, which is an observable list. So it has available the standard observable callbacks. However, in this case, we know that there'll just be one that we can use, and we can call the accept function on this to enter the party. Here we'll use the await as well. And now on the player 2 game object, when I see my received party invite, I can go ahead and click the accept, which will place me in the same party. And when I check that player 1, they will see the second player as well. The content manager has a slight usability improvement. We can always click the download button to get the latest content from the realm to undo most of our changes. But this new content is still here. If I want to completely reset my content to the realm, I can use the drop down and click reset content, which will always make my content equal to what's on the realm. It's possible to catch exceptions from a microservice that failed. For example, let's take a look at a simple microservice client callable that divides two numbers. In case a 0 is passed in, we're going to throw a divide by 0 exception. From Unity, we can call that code in a sample script. Let's create a new public async void do math function, and in this function we'll access our client by using the Beam context default microservices example service extension method to get ourselves a client. And then with that client we can call our divide numbers function and pass it in something that will throw an exception. Let's make sure that we await that expression, and on its own this will fail, but we can catch this using a try catch. And we can catch the platform requester exception. Now we can use this to print out the error as well as the message. Now when we call the do math, we can see that we print out the HTTP error. We can see that we had a status 500. We can control the status code if instead of passing a divide by 0 exception, we can actually pass a microservice exception and say that this is bad input. By saying divide by 0, we can say bad input. Now when we invoke the doMath function, we will see that we have the correct status code in the result. Beamable now provides an advanced way to communicate with the server using an auto-generated SDK from the OpenAPI specification on the Beamable server. To see how this works, let's take an example for changing and fetching the player's inventory. So let's go ahead and create an async void change inventory function. We'll acquire the default Beam context, and from the context, access the service provider and get a named service for inventory API that comes from the Beamable API auto-generated namespace. Let's put this in a variable. When we take a look at the available methods, we'll see that there's very little abstraction in the SDK between the API. So in order to change the inventory, we can use the object put function, which requires the player's gamertag, as well as an inventory update request. So we can get the player ID from the context, and in order to pass in an inventory update request, let's put that in the inspector. Now that is a network call, so let's make sure that we await the response. And after that happens, we can use the API to get the player's latest inventory by using the object get function. And the response for that is an inventory view, which we can put in the inspector so that we can visualize it. Now when we right click and say change inventory, we'll see that our view has been updated. Beamable is now available on the Unity Asset Store, which means you can download it and import it into your projects easily without needing to use the Beamable package installer. Beamable is and will continue to be available on Unity Package Manager as well. Now it's time for the Beamable bonus tip for October. If you have a microservice, you can actually talk to it from Postman with a little bit of setup. If you use the local view documentation button on a running microservice, and then you expand the docs section, this request is actually generating the OpenAPI spec from the microservice. So if you go ahead and copy this request URL, and inside a tool like Postman, you can say Postman import and then paste the link directly. This will pick up the service, so I'll go ahead and import that. And now I can see that inside I have my admin routes and my divide numbers function. If I just try to execute it on its own, it won't work because of invalid tokens. So there is a little bit more setup that we need to do. First, we need to provide the scope header. So add a header called xde scope. Copy this, paste it in here. However, if you try it again, it will now tell you that you need an authorization token. So you can copy that from here and paste it in the token slot. And then the last trick is that for whatever reason, there's an extra slash. So delete the slash here, and now when you send the request, you can see the response. So we can play with these numbers and divide 4 by 2 and interact with our API from Postman. That's all for the October Beamable update. Thank you for watching, and check in next month.